The modern 24-hour day and fixed calendar months are mathematical fictions. They are administrative tools forcing absolute uniformity onto a solar system that naturally fluctuates. The Panchangam operates on a completely different premise. The Panchangam is a traditional Indian almanac that functions as a highly rigorous, geocentric, astronomical computational engine. Look at this orbital model. Instead of relying on evenly sliced hours, the system measures time exclusively through the continuous, varying relative angular velocities of celestial bodies, like the Sun and the Moon as they orbit the Earth. The baseline physical measure in this system is the Vara. A Vara is the solar weekday, tracking the exact duration from one local terrestrial sunrise to the next. This span is divided into 60 units called gatis. A gati is a measure of time equal to exactly 24 minutes. By utilizing these planetary coordinates, this dynamic timekeeping engine maps the universe exactly as it physically breathes and moves, refusing to flatten reality into a static human grid. To track the celestial bodies, ancient Indian astronomers defined a specific operational theater, a 16-degree-wide ecliptic band surrounding the Earth. The ecliptic is the apparent path of the planets across the sky, acting as the ultimate spatial grid. This chart shows the macro-level division of that space. The entire 360-degree circular band is sliced into 12 equal 30-degree zones called rashis. A rashi is a zodiac sign used primarily to map the slow transit of the sun. Moving outward, the exact same space is simultaneously divided into 27 smaller slices. These are the nakshatras. A nakshatra is a lunar constellation occupying exactly 13 degrees and 20 minutes of the ecliptic, tracking the rapid movements of the moon. The mathematical bridge between these two sets of slices is the pada. A pada is a structural unit dividing each nakshatra into 4 exact quarters. Looking at the outermost ring, exactly 9 sequential padas fit cleanly into one rashi block. This dual coordinate grid provides a unified geometrical map. Astronomers log the macro-level solar changes and micro-level lunar movements simultaneously on the exact same surface. The Sun travels completely through one of those 30-degree rashi zones in about 30 days. This exact period of transit is known as the Saura Masa. A Saura Masa is a solar month. Watch this visualization of the Sun's transit along the ecliptic band. The crucial variable for the calendar is the boundary crossing event, the point in time when the Sun leaves one rashi and enters the next. That specific illumination marks a sankramana. A sankramana is the strict astronomical threshold crossing event of the Sun entering a new zodiac sign. While the Sun completes its annual circuit in 365.25 days, the Moon travels much faster, completing its synodic revolution around Earth in roughly 27.3 days. The difference between these two celestial engines generates mathematical friction. 12 lunar months total only about 354 days, which creates an inherent 11-day deficit every year when compared to the solar cycle. Without an advanced intercalary intervention, this recurrent 11-day gap would rapidly detach the lunar calendar from physical earthly seasons, misaligning agricultural cycles and weather patterns. This diagram shows an amavasya, the alignment where the longitudes of the Sun and the Moon are equal. Amavasya is the new moon, and it acts as the starting line for the primary unit of lunar time, the Tithi. A Tithi is not a fixed number of hours. As the moon moves eastward, a Tithi measures the time occupied by the moon in increasing its distance from the Sun by 12 degrees. Planetary orbits are elliptical. Because of this, the moon's physical velocity constantly fluctuates, changing the chronological time required to cover those 12 degrees. Compare these two orbits. On the left, the moon is at perigee, its closest and fastest point relative to Earth. The high speed allows it to clear the 12-degree arc rapidly, compressing the Tithi down to just 53 gatis, or roughly 21.5 hours. On the right, the moon is at apogee, its furthest and slowest point. The exact same 12-degree arc stretches the Tithi up to 65 gatis, or more than 26 hours. This mathematical relationship dictates the remaining parameters. The yoga is the combined sum of the angular positions of the Sun and Moon. The Corona is a measurement representing exactly half of one Tithi. Because a Tithi measures a spatial relationship rather than chronological duration, the calendar naturally flexes. It breathes in perfect harmony with the actual gravitational physics of the solar system. This dual timeline shows the macro solution to the 11-day annual drift. The top track maps solar months with vertical Sankramana markers. The bottom track shows the shorter lunar months continuously drifting left. The mathematical trigger is highly specific. The calendar registers an anomaly when a full lunar month begins and ends without a single solar Sankramana occurring anywhere during its span. When a solar crossing is skipped, the calendar generates an Adhikamasa. This leap month duplicates the lunar cycle roughly every 2.5 years, instantly absorbing the 11-day drift and realigning the earthly seasons. That same mathematical friction occurs on a daily, microscale level. The fluctuating lunar Tithis constantly clash with the fixed terrestrial sunrises. This zoomed-in daily timeline isolates an Adhika Tithi. An Adhika Tithi is an expanded lunar day that starts before one sunrise and ends after the next, stretching a single lunar date across 2 separate terrestrial mornings. The inverse is Akshaya Tithi. Akshaya Tithi is a highly compressed lunar day that begins after one sunrise and concludes entirely before the next. With no sunrise to anchor it, the date is skipped in civil timekeeping. These continuous, interlocking micro and macro intercalations process the astronomical data. By automatically correcting for orbital variables, the system prevents long-term drift and guarantees accuracy for millennia. Returning to the full geometric chart, we see the complete interface of this computational calculation. All 5 components, Vara, Tithi, Nakshatra, Yoga, and Karana, synthesize simultaneously. They form a single, specific timestamp for any given moment based purely on current physical coordinates. The system's architects prioritized absolute orbital precision over the basic administrative convenience of static, equal units. The Panchangam achieves its mathematical brilliance precisely because it refuses to force the physical cosmos into rigid, artificial, uniform boxes. It forces humans to keep time according to the eccentric, breathing rhythms of the universe itself.